You're listening to CosmHush, and I'm about to take you on a journey that sits right at the intersection of theoretical physics, space technology, and a mystery that has top scientists scrambling for answers. What I'm about to tell you sounds like science fiction, but it's happening right now, in real time, approximately 500 miles above your head. In the summer of 2023, something peculiar happened. Satellites began to malfunction. Not all of them, mind you, that would be too obvious, but enough of them that engineers at NASA, the European Space Agency, and private space companies like SpaceX started noticing a pattern. These weren't catastrophic failures. The satellites weren't falling from the sky. Instead, they were experiencing something far more unsettling. A systematic degradation of their systems, a progressive weakening that defied conventional explanation. At first, the scientific community blamed solar flares. When the sun throws a tantrum, and it does frequently, it releases electromagnetic radiation that can indeed interfere with satellite operations. But here's the thing, the solar activity during that period was minimal. The sun was quiet, unusually quiet, yet the interference persisted. Then came the breakthrough. A team of researchers, working across multiple institutions, detected something astonishing. There was a signal, a distinct, unmistakable electromagnetic signal, originating from Earth's orbit, pulsing at precisely 432 Hertz. Not 431, not 433, exactly 432 Hertz. And it wasn't random. It was modulated. It was intentional. It was, in every measurable way, artificial. Let me pause there and give you some context, because if you're not familiar with the significance of 432 Hertz, you're about to be blown away. The standard frequency we use for everything, our power grids, our audio equipment, our telecommunications, is built around 50 or 60 Hertz, depending on where you live. 432 Hertz sits much higher on the electromagnetic spectrum. In the context of radio frequencies, it falls within the VLF band, very low frequency, which is the same frequency range used by military submarines to communicate globally. It's a frequency that travels through water with remarkable efficiency. It penetrates obstacles that would ordinarily block other radio signals. And here's what makes this truly fascinating. It's also a frequency that certain natural phenomena exhibit. Earth's Schumann resonance, the fundamental electromagnetic frequency that pulsates throughout our planet, averages around 7.83 Hertz. But when you take that frequency and multiply it, you get harmonics. And 432 Hertz? It's in that harmonic family. Some researchers have speculated, and I want to be clear that this is on the speculative side of things, that 432 Hertz might resonate with fundamental biological processes. There's been fringe science suggesting it's a healing frequency, and while that particular claim hasn't held up under rigorous scientific scrutiny, the fact remains that this frequency has unique propagation properties that most people have never heard about. But here's where it gets really interesting. The signal's origin was traced back to something called the 3I array, the Triple Integrated Interstellar Instrument. If you've never heard of it, you're not alone. The 3I array isn't widely publicized. It's a network of ground-based and orbital sensors designed to detect signals from space, particularly looking for evidence of extraterrestrial transmissions, gravitational waves, and various forms of cosmic radiation. ATLAS, the Asteroid Terrestrial Impact Last Alert System, was integrated with this network in 2021, creating what became known as 3I/ATLAS. Now, ATLAS was originally designed to identify near-Earth objects, asteroids, comets, things that might impact our planet. But when the system was upgraded and integrated with 3I's surveillance capabilities, something unexpected happened. The detection arrays became hypersensitive. They didn't just identify incoming threats from space. They began detecting something else, something transmitting. The signal, researchers determined, was being generated from a transmission array located in the Arctic. Not publicly acknowledged, but there nonetheless. This facility, staffed by a rotating team of scientists and military personnel, had been conducting experiments with VLF frequency modulation. The stated goal was to study ionospheric behavior. The unstated goal, well, that's where things become complicated. You see, the 432 Hz signal wasn't happening accidentally. It was deliberate. The array was specifically engineered to generate this frequency, maintain it with extreme precision, and modulate it in ways that would send cascading effects through the magnetosphere and into Earth's orbital space. And the consequences have been significant. Satellites in low Earth orbit, the same satellites we depend on for GPS, weather forecasting, telecommunications, and climate monitoring, began experiencing cascading electronic failures. But not immediate failures, gradual ones. The kind that suggests the system was being overwhelmed by a persistent, coherent electromagnetic field that they simply weren't designed to withstand. Communications satellite operators started noticing increased error rates in their signal processing. Imaging satellites experienced sensor drift. Navigation satellites showed inconsistencies in their atomic clock readings, and these are the most stable devices we've ever built, yet even they couldn't resist this signal's effects. The cumulative impact on the global network became apparent. Billions of dollars worth of space infrastructure was being degraded by something we couldn't turn off because we couldn't entirely shut down the source without creating massive diplomatic and military repercussions. Let me explain why this is so much more complicated than it initially appears. The Arctic facility that's generating the 432 Hertz signal doesn't belong to NASA or the ESA. It's a sovereign military installation. Multiple governments have vested interests in what the signal does and how it operates. On the surface, the official narrative is that it's a scientific experiment designed to understand ionospheric heating and its potential applications. But when you start digging into the declassified documents, the leaked communications, and the patterns of satellite degradation, a more complex picture emerges. The 432 Hertz signal has specific effects on satellite electronics. It doesn't destroy them. It doesn't cause a sudden system failure. Instead, it induces what engineers call electronic fatigue, a progressive weakening of components that eventually leads to failure. More importantly, it affects specific types of satellites more severely than others. Military reconnaissance satellites are hit harder than commercial communications satellites. Navigation satellites experience more drift than meteorological satellites. This selectivity is the truly disturbing part. It suggests the signal isn't just a blanket electromagnetic pulse. It's been specifically modulated to target certain frequency responses, certain circuit architectures, certain types of space-based systems. Someone knew exactly what they were creating, and they designed it to achieve a particular goal. The implications are staggering. If you can degrade the functionality of an adversary's space infrastructure without destroying it, without leaving obvious evidence of deliberate sabotage, you've essentially created an invisible weapon. A weapon that operates in a legal gray area because technically you're not attacking anything, you're just broadcasting at a particular frequency. Now, here's where the science gets even more nuanced. The 432 Hz frequency, when propagated through the ionosphere at the right intensity and modulation, creates something called Alfvén waves in the magnetosphere. These are electromagnetic waves that propagate through plasma, and the magnetosphere is essentially a vast sea of plasma. Alfvén waves can travel thousands of kilometers, and they interact with charged particles in ways that scientists are still fully understanding. When you have a coherent, sustained 432 Hz signal creating Alfvén waves on a global scale, you're essentially conducting a planetary-scale physics experiment. The effects aren't localized. They ripple outward. They create resonance patterns. They interact with other natural electromagnetic phenomena. And here's what makes it even more intriguing. Alfvén waves can couple with other wave phenomena in the upper atmosphere, creating secondary effects that cascade down into lower altitudes. Some researchers have suggested that the 432 Hz signal might even be affecting Earth's ionosphere in measurable ways. The ionosphere is critical for reflecting radio waves and enabling long-distance communications. Alter it, and you alter the entire information ecosystem of a planet. You could potentially jam or degrade radio communications across entire regions. You could disrupt navigation systems. You could even affect the very fiber optic networks that carry global internet traffic, because those networks rely on GPS for synchronization. There's a cascading effect. A signal that starts as a broadcast at 432 Hz becomes something far more complex as it interacts with Earth's magnetosphere, ionosphere, and the systems we've built that depend on these regions of space. The question that keeps scientists up at night is this: why? What's the end game here? Several theories have emerged in classified circles. The first is that this is a defensive measure. If another nation is developing space-based weapons, satellite interceptors, kinetic kill vehicles, or other systems designed to attack satellites, then degrading their operational capacity before they can deploy it makes strategic sense. It's a preventive strike disguised as a scientific experiment. The second theory is more aggressive, that the Arctic facility is the opening move in a long-term campaign to achieve what military theorists call space dominance. If you can degrade an adversary's satellite network without overt military action, you control a critical domain without ever firing a shot. It's the ultimate asymmetric advantage in modern warfare. The third theory, and this is where it gets genuinely unsettling, is that this is a test, a proof of concept for something larger. If you can use 432 Hertz to affect satellites, what else might you be able to affect? Could you degrade ground-based communications? Could you interfere with power grids? Could you create atmospheric effects that we haven't even considered yet? The signal continued for 18 months. During that time, multiple satellite operators reported ongoing degradation of their space-based assets. Insurance claims were filed. Governments lodged diplomatic protests. Behind closed doors, negotiations were happening that never made it to the public record. Then, abruptly, the signal stopped. In March of 2025, the 432 Hertz transmission from the Arctic array ceased. No official explanation was provided. No acknowledgement that it had ever occurred. But satellite operators noticed the difference immediately. Their systems began recovering. Electronic failures diminished. The global satellite network started returning to normal operational status. What happened? Did the experiment conclude? Did diplomatic pressure force a shutdown? Did a breakthrough in international relations lead to an agreement we'll never know about? The truth remains classified, buried behind national security concerns, diplomatic sensitivities, and the murky world of space-based military operations. But here's what matters right now in this moment. The fact that this was possible. The fact that a single ground-based facility could generate a signal that affected hundreds of satellites, billions of dollars worth of infrastructure, and the information flow of the entire planet. The fact that it happened, and most people never knew about it. The fact that it could happen again, and we might not see it coming until our systems start failing. We live in an era where space infrastructure is critical. More critical than most people realize. Your smartphone uses GPS. Your car's navigation relies on satellite signals. Your financial transactions are synchronized using atomic clocks in Earth orbit. Weather forecasting, climate monitoring, disaster response, telecommunications, all of it depends on satellites. And those satellites are vulnerable, not to physical attack, but to something far more subtle, electromagnetic warfare. The 432 Hertz signal, whether intentional or not, revealed a critical weakness in our technological infrastructure. We've spent decades building an increasingly complex network of space-based systems, but we've never really hardened them against this type of attack. We've protected them against radiation. We've shielded them against solar flares. But a carefully crafted electromagnetic signal at just the right frequency? That was something new. That was something we didn't see coming. The incident with 3I/Atlas didn't destroy our satellite network. It degraded it. It demonstrated that our space infrastructure is far more fragile than we'd like to admit. It showed that a sufficiently motivated actor with the right resources could create chaos without conventional weapons. No explosions, no military strikes, just a persistent, coherent electromagnetic signal. In the months following the cessation of the 432 Hertz transmission, a global conversation began quietly in specialized circles about space-based electromagnetic security. How do we protect our satellites from this type of attack? How do we harden their electronics? How do we ensure that the infrastructure we depend on can withstand not just random cosmic events, but deliberate, targeted attacks? These are questions without easy answers. The hardening process is expensive. It requires redesigning satellite electronics, implementing radiation-hardened components, developing sophisticated shielding techniques. And it has to happen on a global scale across thousands of satellites, with the cooperation of government agencies and private companies that have vested interests in keeping their operations secret. Meanwhile, the Arctic facility remains operational. The 432 Hertz array still exists. We don't know if it's been dismantled or simply powered down. We don't know what lessons its creators learned from the experiment. We don't know if other nations are building similar systems. What we do know is this: we've entered a new era of space-based security challenges. The old paradigms don't apply anymore. You can threaten satellites without shooting them down. You can degrade a nation's technological infrastructure without conventional military action. And the person or nation responsible for that degradation might never be clearly identified or held accountable. The 432 Hertz signal was a wake-up call. It told us that space isn't just a new frontier, it's a new domain of conflict. And unlike air, land, or sea, space operations happen at such vast distances, with such technical complexity, that civilian populations often don't even realize they're affected until something goes catastrophically wrong. We have no idea how many people's lives were altered by the degradation of satellite systems caused by the 3I/Atlas signal. Climate models that rely on satellite data became less accurate. Search and rescue operations that depend on GPS had to adapt. Financial transactions that use satellite-based timing became less reliable. These weren't dramatic disasters that made headlines. They were subtle degradations of the systems we depend on daily. And that's perhaps the most unsettling aspect of this entire situation. The most powerful weapon isn't always the one that explodes or causes visible damage. The most powerful weapon is the one that silently disrupts the invisible infrastructure that holds civilization together. The 432 Hertz signal demonstrated that we've built a technological civilization that's utterly dependent on space-based systems, yet we've done relatively little to protect those systems from deliberate electromagnetic attack. We've created a critical vulnerability without even realizing it. And now that the vulnerability has been exposed, we're scrambling to figure out how to close the gap. As we look toward the future, several critical questions loom. Will the 432 Hertz signal return? Will other nations replicate the technology? Will it be modified, improved, or adapted in ways that make it even more effective? Will the international community establish clear rules for space-based electromagnetic operations, or will this become another arena of unregulated conflict? The 3I/Atlas incident remains only partially declassified. The full extent of the damage, the complete technical specifications of the signal, and the diplomatic negotiations surrounding its use remain in classified files. What we have are fragments of information, pieced together from leaked documents, scientific publications, and interviews with people who were there but can't say much. But the fragments tell a powerful story. A story about how dependent we've become on technology we barely understand. A story about how that technology can be turned into a weapon through nothing more than a carefully crafted electromagnetic signal. A story about how our space infrastructure, which seems so robust and reliable from down here on Earth, is actually quite fragile when subjected to the right kind of attack. The 432 Hertz signal isn't a doomsday scenario. The satellites survived. The global system adapted. Life continued. But it's a reminder that we're always one innovation away from a crisis. We're always vulnerable to something we haven't anticipated. And the vast reaches of space, which once seemed like a place of unlimited opportunity and infinite resources, are now clearly a frontier where conflict happens just as readily as cooperation. As I sit here, recording this narrative, somewhere above the planet, thousands of satellites are continuing their orbits. They're maintaining the infrastructure that allows modern civilization to function. And somewhere on Earth, scientists and military personnel are studying the data from the 432 Hertz incident, trying to understand what it means and how to prevent it from happening again. The story of 3I/Atlas isn't finished. It's just beginning. The implications are still unfolding. And the next time you use GPS, check the weather, or rely on satellite communications, remember that these systems are far more vulnerable than you might think. Remember that, in the domain of space, the rules of engagement are still being written. And remember that sometimes the most powerful weapons don't make a sound at all.